Hello everyone. With Go 1.22 set for release in February 2024, it's the perfect time to check out the changelogs. Join me for a quick overview of what's new and what has changed. So let's dive in. The biggest change for me is the for loop variable. In earlier version, the for loop variables were established once and then updated in each subsequent iteration. So as start of the first iteration, a variable was initialized and then reused throughout the iterations. This approach often led to emergence of bugs in the code due to how peculiar the for loop variables were and how Go handled it differently. With the release of Go version 1.22, a significant enhancement has been implemented. Now, in each iteration of the loop, a new variable is created, mitigating past issues and promoting a more robust and bug-resistant coding environment. This was an experimental feature in 1.21, but with release of Go 1.22, this has been made generally available. Let's look at an example to understand the difference. Here I have a values which is an int slice containing value 1, 2, 3, 4, 5, and inside the for loop we are starting a Go routine, printing the value of iteration variable val. As you can see from the output, the value is unpredictable since val is only initialized one and then reused. So the output is 45555. So by the time the first Go routine was started, the value in val was 4 and all of the other ones captured the last value in val, which is 5. This was quite confusing and led to bugs in production code. Starting Go 1.22, this won't be the case as a new variable will be initialized each time. So if you do the same thing and start a Go routine inside each iteration, it will capture a separate new value since the variable is not shared across iterations. You can experiment using pointers. If you run a loop with older version of Go and then save the address of val, you will see each iteration the address is the same. But if you do that with the new version or version 1.22, each iteration will have a different address, which points to that each iteration a new variable is created. The latest enhancement in Go introduces the ability to use range keyword with integers. You can now range over integers. This update simplifies the process of iterating a specific number of times, providing a cleaner and more straightforward syntax. Now developers can easily utilize the range keyword for integer-based iteration, streamlining the code and enhancing the readability of loops in Go. Here is an example of the same. As you can see, we are doing for I range 10 and printing I. As you can see from the output, the first value is 0 and the last value is 9 since it's a half open range and it starts from 0. Although an experimental feature, I think function iterators is something to talk about. As I told you, this is an experimental feature and can be enabled with Go experiment flag with value range func followed by Go command. It allows for an inter-package import which exports types and helper functions to help you implement function iterators. The two types exported are sequence and sequence2. First one accepts a value, the second one accepts a key value pair. Inside it, it takes a function or a callback and returns a boolean. A few examples from the changelog are here. You can try it out yourself in the playground. I will attach a link to Go Playground for version 1.22 in the video description so you can try all these examples out yourself. As it is experimental feature, I don't want to go into depths of this feature at this point. But again, I will provide all the links required to go over it in depth if you want to. Go version 1.22 will also include a second version of MathRand. The previously deprecated read function has now been completely removed in the latest version. As an alternative, developers are encouraged to leverage the read function from CryptoRand package or utilize the exported unsigned int64 from MathRand v2 version to create a random sequence of bytes. This transition ensures more streamlined and secure practices, offering viable alternatives for cryptographic random number generation within your Go projects. Let us look at some examples. The example on the left uses the read function exported from crypto.rand package to create a sequence of 5 bytes or 5 random bytes. On the right, we are using unsigned int64 function from the MathRand v2 package to generate random sequence of bytes for a given length. These two alternatives can be used instead of using the deprecated or removed read function. The pattern used by servmux function now accepts method and wildcards. As an example of this enhancement is demonstrated with pattern like post, which is the method, and then item/create, which is the path. This showcases the improved versatility in routing. Please note, registering a handler with get method now automatically registers it with the head method, streamlining the process and aligning with the common used patterns in servmux function. Pattern like this can be supplied in the path and then can be fetched using the path value method on the request object. Let's look at an example of the same. As you can see, path has pattern ID and then we are fetching the ID using r.pathValue on the request object, and this gives us the value of ID. Multiple match wildcard, that is ellipsis, if used should be the last one and will match all remaining segments of the path. It too can be accessed with the pathValue method on the request object. Let's look at an example for the same. As you can see, we are using ellipsis here and then we are assessing the value using pathValue passing the path, which is what we used here. And that should give us all the matches or all the remaining matches segment. Next, here we have an example of exact match. We are using wildcard $, to do exact match for this route. If we don't provide a $, it would be a prefix match. Please note that preference is always given to exact match. A new method concat2slices standard lib package has been added that concatenates values from multiple slices into one slice. As we can see, we here have 3 int slices S1, S2, S3, and we are concatenating them using the concat function from slices, and as such the output is all the elements from each slice are concatenated into one. Functions that shrink the size of slice from the slice package now zero the elements between the new length and the old length. So functions like delete, deletefunc, compact, compactfunc, replace now zero the elements between the new length and the old length. In earlier version, they only used to update the length and leave the elements as it is. Let us look at some example. So as you can see here, in Go version 1.21, we have a source slice and then we delete from source using the delete function, and the old slice still holds the deleted values. Moving over to Go 1.22, you can see when we deleted, the old values that were deleted from the new slice are also set to 0. So the function is doing additional cleanup for you. Here we have few more examples of the compact and replace functions exported from the slices package. As you can see, the elements removed are set to 0 for both. A significant change has been introduced in the insert functionality for slices. Now it consistently panics if the specified argument I is out of range or the index is out of range. In contrast to previous behavior, where no panic occurred if there was no element to be inserted, the updated behavior ensures that it's more predictable and provides an error-resistant outcome. This adjustment also contributes to code robustness by enforcing clear boundaries and offering developers a more reliable and error-proof experience when utilizing the insert functionality. Let us look at an example again. As you can see, in older version of Go, if you were inserting at an index that was out of bound of source slice, it would be a no op and nothing would happen. But with the newer version, that is 1.22, if you try to do that, since 4 is out of range, the code will panic. So instead of silently failing, it will fail loudly. Let's now talk about enhancements made to tools and runtime. The Go test cover command has been enhanced to provide coverage summaries for packages that lack test files, offering a more comprehensive view of test coverage. The Trace Tools web UI has undergone a refreshing update, ensuring a modern and user-friendly experience for developers leveraging its capabilities. The Wet tool, a static analysis tool, now includes additional warnings. It includes warning for loop variables, new warnings for missing values after append operation to slices, warning related to deferring time.sense, promoting better time-related practices. It will also warn you for mismatched key value pairs in log/slog calls, enhancing code consistency and reliability. The runtime in Go has gone up performance enhancements where type-based garbage collection metadata is now kept closer to the heap object. This results in a notable improvement in CPU performance, with gains ranging from 1 to 3% for Go programs. Beyond the performance boost, this change has an additional benefit of reducing the memory overhead. For majority of Go programs, the memory footprint is slowed by approximately 1%, achieved through deduplication of redundant metadata. So, overall, by optimizing the placement of garbage collection metadata, this update not only enhances runtime performance but also contributes to a more efficient utilization of system resources, providing tangible benefits to overall efficiency of Go programs. Profile-guided optimization, or PGO builds in Go, have been now refined to achieve a higher rate of devirtualization for calls compared to previous capabilities. The impact of enhancement is reflected in performance improvement for a representative set of Go programs. Enabling PGO now results in noteworthy enhancement, with most programs experiencing performance gain ranging from 2 to 14% when PGO is enabled. This improvement underscores the effectiveness of PGO in optimizing call devirtualization, showcasing its positive impact on broad range of Go programs and reinforcing the significance of incorporating PGO for enhanced performance. That's all I wanted to cover in this video. But as mentioned earlier, I will provide all the links to all the changes that have been made so you can go through them in depth if you want. For now, let's summarize everything we went over. The first major change is to loop variable for the for loop, which has been a problem for a long time. Next, we also saw some language enhancements with range over integers, which will make Go code using for loops for limited number of iterations more concise and clear. We also saw express routing and new functionalities or new functions added to the slices package, along with few more things. That's it for this video. I hope you enjoyed it. Please feel free to ask any questions you may have by posting a comment under the video or reaching out to our Discord server. Thanks again. Until next time, happy coding.